In July 1944, a quiet crisis unfolded among the ruins of a German military complex in northern France, one that would signal the death knell of the Third Reich's strategy of static fortification. German engineers, tasked with assessing the damage to the WWII launch site, found themselves staring at a scene of destruction that defied the known laws of ballistics and structural engineering. The target, a fortress of immense strength with concrete walls 5 meters thick, had been reduced to a twisted skeleton of steel and pulverized stone. But the cause of this devastation was the true source of their alarm. The bomb responsible had not even struck the bunker directly. Instead, it had impacted 50 yards away, creating a crater 100 feet across and 80 feet deep. The shockwave had traveled through the earth, liquefying the soil and shaking the massive concrete structure until its foundations failed and its walls collapsed, effectively swallowed by the ground beneath it. When the engineers recovered fragments of the casing, they realized that the British had introduced a weapon that rendered the concept of a near-miss obsolete. This was the debut of the Tallboy, a weapon designed not merely to explode, but to generate localized earthquakes, ensuring that no bunker in Europe, regardless of how much concrete was poured, could protect its occupants. To understand the magnitude of this shift in warfare, one must first understand the stalemate that existed in aerial bombardment. Prior to 1944, the British problem was a matter of brutal mathematics. Regarding fortifications, as the war progressed, Germany had encased its most vital assets, U-boat pens, WWII pen launch sites, and capital ships in protective shells of reinforced concrete that conventional munitions could not breach. A standard British 4,000-pound cookie blockbuster bomb was essentially a thin metal can filled with high explosives, approximately 75% of its weight being the explosive charge itself. When such a weapon struck a hardened target, it detonated instantly upon contact, expending its energy in a surface blast that might scorch the concrete or create a shallow crater, but ultimately bounced off the structural integrity of the roof. The physics of penetration followed a law of diminishing returns. Simply making a bomb heavier did not result in a linear increase in damage. To breach a roof 7 meters thick using conventional bomb designs, calculations suggested one would need a weapon of impossible size, weighing hundreds of thousands of pounds, which no aircraft of the era could lift. The Allies were hitting a literal and metaphorical wall, forcing commanders to accept that targets like the submarine pens at Lorient or the battleship Tirpitz were essentially indestructible from the air. The solution to this impasse came from outside the traditional circles of ordnance design, from the mind of Barnes Wallis, a Vickers aeronautical engineer, previously known for airships and the geodesic structure of the Wellington bomber. Wallis posited that the atmosphere was a poor conductor of shock waves, dissipating energy rapidly in all directions, whereas solid matter, earth and rock could transmit a shock wave with devastating efficiency. His concept, which he termed the camouflage effect, relied on a delay. If a bomb could be made aerodynamic enough and heavy enough to survive impact at supersonic speeds, it could penetrate deep into the earth before detonating. The resulting explosion, trapped underground, would expand to create a massive subterranean cavern. The support for any surface structure would vanish into this void, causing the target to collapse under its own weight, the hangman's drop. This was a radical inversion of all previous bombing logic, which prioritized a direct hit. Wallis argued that a bomb buried deep next to a target was more lethal than a bomb exploding on its roof. Despite the brilliance of the theory, Wallis faced immense bureaucratic inertia. His original proposal for a 10-ton bomb was rejected by the Air Ministry, with figures like Air Chief Marshal Sir Arthur Harris and scientific advisor Frederick Lindemann dismissing the ideas as fantasy or a waste of resources. It was only after the success of Operation Chastise, the famous Dambus raid which utilized Wallis's bouncing bomb principles, that the political capital was acquired to greenlight the earthquake bomb. Weapon that emerged from the workshops of Vickers was a marvel of metallurgical and aerodynamic engineering, distinct from every other bomb in the Allied arsenal. The Tallboy was 21 feet long, weighed 12,000 pounds, approximately 5,443 kilograms, and possessed a diameter of 38 inches. Unlike conventional bombs that maximized explosive filler, the Tallboy prioritized structural integrity for penetration, with only roughly 43% to 45% of its weight consisting of explosives. The casing was cast from a single piece of high-tensile steel, with a nose section exceeding 4 inches in thickness to withstand the immense forces of impact. To ensure the bomb fell with the precision of a rifle bullet, the tail fins were set at a 5-degree offset, inducing a spin of 60 revolutions per minute during descent. This gyroscopic stabilization eliminated the tumbling and yawing that plagued standard bombs. bombs, allowing the Tallboy to achieve terminal velocities approaching Mach 1, or roughly 750 miles per hour. Upon impact, the kinetic energy alone was staggering. A 5.4-ton mass, moving at that speed, delivered approximately 740 megajoules of energy, a force comparable to a significant explosion before the warhead even detonated. The explosive filling of the Tallboy was as specialized as its casing. It utilized Torpex D1, a potent mixture comprising 42% RDX, 40% TNT, 18% aluminum powder, and wax stabilizers. This compound was approximately 50% more powerful than standard TNT, giving the 5,200-pound charge an effective blast equivalent to nearly 8,000 pounds of TNT. The manufacturing process was painstakingly slow and dangerous. The molten explosive had to be poured by hand into the appended casings, followed by a layer of pure TNT and a woodmeal wax seal. The cooling process alone took a month, creating a severe bottleneck in production. Furthermore, the steel casings required specialized forging capabilities found in only 2 factories in Britain. Vickers Don Valley Works in Sheffield and the Clyde Alloy and Steel Company in Glasgow. The precision required for the nose or give the curved shape, designed for optimal aerodynamics, meant that these 6-ton castings had to be machined to tolerances usually reserved for fine instruments, not heavy ordnance. Between 1944 and 1945, only about 1,000 Tallboys were manufactured, making each one a strategic asset that crews were ordered to bring home rather than jettison if a target could not be attacked. Despite the terrifying risk of landing with a live earthquake bomb aboard, the operational debut of the Tallboy in June 1944 validated the years of struggle Wallis had endured. The target was the Saumur Railway Tunnel, a critical artery for moving German panzer divisions to the Normandy front. On the night of June 8, the legendary 617 Squadron, known as the Dambusters, dropped the new weapons with devastating accuracy. One Tallboy bored through 60 feet of solid hillside before detonating inside the tunnel itself, while others severed the tracks completely, creating craters that blocked the line for the remainder of the campaign. The German armored reinforcements were halted, a tactical victory that had direct strategic implications for the survival of the Allied beachhead. This success was followed immediately by attacks on the German V-weapon sites. At Mimoix, a massive underground complex designed to house the V3 London gun, a supergun capable of firing 600 shells an hour into London, was obliterated. The Tallboys penetrated 15 meters of chalk and rock, collapsing the tunnels and burying hundreds of workers, effectively ending the threat to London before the gun could fire a single shot. The sheer power of the weapon allowed the RAF to dismantle the VIAF and infrastructure site by site, forcing Hitler to abandon the construction of fixed concrete bunkers for missile launches entirely. Perhaps the most dramatic chapter in the Tallboys' history was the hunt for the Tir, the sister ship to the Bismarck and the largest battleship in the German fleet. Hidden in Norwegian fjords, the Tirpitz acted as a fleet in being, tying down vast Royal Navy resources simply by existing. Conventional bombing and submarine attacks had failed to sink her. However, the Tallboy changed the equation. In a series of raids operations, Paravane, Obviate, and finally Catechism, in November 1944, Lancasters from 617 and 9 squadrons pursued the ship. The final blow came when 2 Tallboys pierced the ship's armor and a third detonated deep in the water alongside the hull. The shockwave from the near miss buckled the hull plates, while the direct hits triggered a magazine explosion that blew the massive Caesar turret completely off the ship. The 42,000-ton Leviathan capsized in minutes, trapping over 900 sailors inside. The sinking of the Tirpitz demonstrated that even the thickest naval armor was no defense against a bomb that arrived at supersonic speed and detonated with the force of an earthquake. The kinetic energy involved in these impacts was a critical factor, with a mass $m of approximately 5,443 kilograms and a terminal velocity $v of around 335 meters per second, 750 miles per hour. The energy at the moment of impact was immense, allowing the bomb to punch through armor and concrete that would shatter a conventional casing. This physical reality forced the German High Command into a state of strategic paralysis. The devastation wrought by the Tallboy extended to the German U-boat pens, the very targets that had inspired the bomb's creation. These massive concrete cathedrals, with roofs up to 7 meters thick, were considered impervious, Yet, at bases like Brest, Bergen, and Farge, the Tallboy proved otherwise. At the Valentine bunker in Farge, the largest fortified U-boat facility in Germany, 2 Grand Slam bombs, the larger 22,000-pound successor to the Tallboy, and several Tallboys tore through the 4.5-meter thick reinforced concrete roof sections, rendering the facility unusable. The psychological impact on the German leadership was profound. Albert Speer, the Minister of Armaments, attempted to counter the threat by ordering even thicker fortifications, dubbed Sonderbau special construction, but the resources required were astronomical and the timelines impossible. The Tallboy had effectively won the engineering war. British bombers could destroy fortifications faster than German. Industry could pour concrete. Infrastructure targets were also dismantled with frightening efficiency. The Dortmund-Ems Canal, a vital waterway transporting coal and steel from the Ruhr to the rest of Germany, was repeatedly struck. Unlike conventional bombs that merely breached the canal bank's damage, that could be repaired in days, the Tallboys detonated deep under the canal bed. The resulting cavities caused massive sections of the canal to collapse, requiring complete reconstruction that took months. The resulting disruption to German industry was catastrophic, severing the flow of raw materials at a time when the Reich was already starving for resources. Similarly, the Bielefeld viaduct was destroyed when a Grand Slam landed nearby, its earthquake effect shaking the brick foundations until spans of the bridge simply crumbled, cutting a main rail line from Hamm to Hanover. The delivery of these weapons required a level of airmanship that matched the engineering brilliance of the bomb itself. 617 Squadron, utilizing the stabilizing automatic bombsight SABs, achieved accuracy levels that were virtually unheard of in World War II. While the average bomber command crew might place 30% of their bombs within 3 miles of a target, the Tallboy crews were placing 12,000-pound weapons within 95 yards of a target from an altitude of 18,000 feet. The best crews could achieve groupings as tight as 36 yards. This precision was achieved by a truly multinational force. The squadron was a microcosm of the British Commonwealth, with significant numbers of Canadian, Australian, and New Zealand aircrews serving alongside their British counterparts. For instance, the squadron was commanded during the height of the Tallboy campaign by Air Commodore Johnny Foote, a Canadian ace and one of the most decorated officers in the RCAF. Australian pilots like David Shannon and Mick Martin, veterans of the original Dambusters raid, continued to fly these high-risk precision missions. The effort to deliver the Tallboy was not solely a British endeavour but a coordinated exertion of the Empire's best aviators. German analysis of the Tallboy attacks revealed a deep sense of technological inferiority. When German metallurgists examined the fragments recovered from crater sites, they identified steel alloys and machining tolerances that their own war-ravaged industry could no longer replicate. They noted the evidence of high-speed spin and the incredible depth of the craters, realizing that the British had developed a weapon that bypassed their defenses entirely. The recommendation from German analysts was stark: abandon fixed fortifications. There was no countermeasure. The realization that billions of Reichsmarks and millions of man-hours had been poured into bunkers that were now essentially death traps was a bitter pill for the Nazi leadership. The Tallboy had forced a complete strategic revision, pushing Germany toward mobile launch platforms for their which were inherently less accurate and efficient, further degrading their ability to strike back at Britain. The legacy of the Tallboy extended far beyond the capitulation of Germany in 1945. The United States, which had no direct equivalent during the war, save for the rocket-assisted Disney bomb, which saw limited and mixed success, would eventually adopt the principles of the earthquake bomb for future conflicts. The operational data from Tallboy drops informed the development of the Tarzan-guided bomb used in Korea, and decades later, the GBU-28 deep-throat bunker buster, developed hastily during the 1991 Gulf War to target Iraqi command centers. The central tenet of Barnes Wallis's philosophy that destroying a hardened target requires deep penetration and subsurface detonation remains the governing principle of anti-bunker warfare today. The GBU-57 massive ordnance penetrator, currently in the U.S. arsenal, is the spiritual descendant of the Tallboy, carrying the DNA of 1944 engineering into the 21st century. By the end of the conflict, 854 Tallboys had been dropped with a reliability rate exceeding 99.7%, a testament to the build quality of the weapon. Only 2 duds were ever recovered. From the shattered concrete of the V2 bunkers in France to the overturned hull of the tear pits in the freezing waters of Norway, the bomb had left a trail of destruction that conventional explosives could never have achieved. It was a triumph of lateral thinking, proving that when faced with an immovable object, the solution was not to hit it harder on the surface, but to undermine the very ground it stood on. The Tallboy did not just destroy targets, it dismantled the confidence of an enemy who believed they could build their way to safety. In the final analysis, the craters left by these bombs were graves for the concept of the impregnable fortress.